In a series of videos, I will discuss key factors that drive the success rate and productivity of metal additive manufacturing builds, and some of the critical guidelines that designers should follow to create production components efficiently. Today I will discuss Factor 1, residual stress. Residual stress is a natural consequence of the rapid heating and cooling in the laser powder bed fusion process. Each new layer is created by moving the focused laser across the bed, melting the top layer of powder and fusing it to the layer below. Heat flows from the hot weld pool down into the solid metal below, and so the molten metal cools and solidifies. This all happens very rapidly in a matter of microseconds. Residual stresses can be destructive. As we add layers on top of one another, the stresses build up and can lead to distortion of the part, causing it to curl up at the edges and pull away from its supports. In more extreme cases, the stress can exceed the strength of the part, leading to catastrophic cracking of the component or distortion of the build plate. So how do we minimize residual stresses in additive manufacturing? One way to tackle this is by varying our scanning strategy, choosing a method that is best suited to the part geometry. When we are filling in the center of our part, an activity known as hatching, we typically move the laser back and forth. The pattern that we choose affects the length of the scan vectors, and hence the level of residual stress that we are likely to build up in our component. Strategies with shorter scan vectors will generate less residual stress. There are different types of hatching, including the meander hatching pattern, suitable for small and thin features, the chessboard hatching pattern, suitable for large parts, and stripe hatching pattern, suitable for large parts and offering a higher build rate than the chessboard. We can also rotate the orientation of our scan vectors from one layer to the next, so that stresses are not all aligned in the same plane. A rotation of 67 degrees is typically used between each layer to ensure that it is many layers before the scanning direction is exactly repeated. Heating of the build plate is another technique used to reduce residual stresses, whilst post-process heat treatments can also relieve the residual stresses that have built up. My key tips to design out residual stress include: avoid large areas of uninterrupted melt, be careful about changes in cross-section, use thicker build plates where stresses are likely to be high, and select an appropriate scan strategy. Watch out for the next video featuring optimized part orientation for additive manufacturing.